Okay, we're at the working it out section, so stop the video and you try and draw a Lewis structure for carbon dioxide, CO2. Just go through your steps, draw the dot notation, count the electrons, make a skeleton, fill octets, and then make sure that the numbers match. If they don't, you may have to make a multiple bond. Carbon dioxide has one carbon. Carbon has 4 dots. It's got 2 oxygens. Oxygens are column 6, so they have 6 dots. So 2 times 6 gives me 12 electrons, and I have 4 electrons from my carbon. 4 and 12 is a total of 16 electrons. So my structure, when I'm all done, should have 16 electrons in it. I'll make a skeleton. If I look at the periodic table, I notice that carbon is closer to the middle of the table than oxygen is. I also know that carbon wants to make 4 bonds, so I'll make as many bonds to carbon as I can by putting both oxygens on the outside. Another little hint is this. Lots of the time, this works. If it's only a binary compound, in other words, it has only 2 elements in it, the first one listed goes in the middle, the last one listed goes on the outside. It works a lot of the time. Okay, now I have a skeleton, and I'm going to fill octets. This carbon has 2 sides full, but 2 sides not full. So I'm going to put a pair of electrons on the remaining 2 sides. Full octet. The oxygens, both of them are in the same boat. They both have 2 electrons in the bond, but need 6 more. So I put 6 more in 3 lone pairs, and I do that for both oxygens. Okay, now I make a count. I need to have 16 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I get too many electrons. So I have to fix that. Here's what I do. I'm going to pick a pair of electrons from 2 atoms that are bonded to each other. I'll go with the right-hand oxygen and the carbon in the middle, and then replace those 2 missing pairs with a lone pair. And count again. 2, 4, 6, 8, 10, 12, 14, 16, 18. It's still too many electrons. Well, I have an option here. I could make a triple bond between this carbon and oxygen by eliminating these 2 lone pairs, or I could go to the other side and make another double bond to the other side. Well, the other double bond on the other side is more symmetrical, so that's good. And the other thing that would do is it allow both oxygens to make 2 bonds. And remember, oxygens are group 6, and they prefer to make 2 bonds. So I'll go to the other side. I'll erase this pair. I'll erase a pair from the other row, and then I'll replace those 4 missing electrons with 2 electrons. And I'll redo my count. 2, 4, 6, 8, 10, 12, 14, 16. That's the correct number, so that's the right structure for carbon dioxide. Try to draw the Lewis structure for carbon monoxide, CO. Just follow your rules, and I'll give you the answer in a little bit. Carbon monoxide has got a carbon in it, 1 carbon with 4 dots, so that's 4 electrons, and it's got 1 oxygen. Remember, oxygen's column 6, so that makes 6 dots. So 4 electrons and 6 electrons is a total of 10 electrons. That's how many should be in my structure. The skeleton is a no-brainer here because we only have 2 atoms, so we just stick them to each other. Then we have to fill octets. Both atoms need 6 more electrons, 3 lone pairs, to gain stability, to gain a full octet. Then when I count, I have 2, 4, 6, 8, 10, 12, 14 electrons, which is too many. So I need to make multiple bonds. Take away a pair from the O and the C, replace it with another bond, and count. 2, 4, 6, 8, 10, 12. I need 10 electrons. This is still too many. Erase, erase, and then put another bond in. Now I count again. 2, 4, 6, 8, 10. Finally, I got the numbers to match. That's the structure of carbon monoxide. Draw the Lewis structure for hydrogen. Well, hydrogen's got 2 hydrogen atoms. Hydrogen atoms have 1 dot because they're column 1, 1 valence electron. So that gives me a total of 2 valence electrons in my structure. Again, the skeleton is easy because there's only 2 atoms. It's H2 that I'm drawing here. So H bonded to another H, and that's it. This hydrogen's stable because it only needs a duet. So is this one, and that electron pair represents our 2 electrons. Try the Lewis structure for HCN, hydrogen cyanide. Hydrogen cyanide's got a hydrogen, a carbon, and a nitrogen. Hydrogen has 1 dot, column 4 carbon has 4 dots, and column 5 nitrogen 5 dots. So these 5 electrons plus the 4 electrons from carbon plus the 1 electron from hydrogen all adds up to 10 electrons total. Skeleton structure? Well, I'm going to put carbon in the middle because I want to make as many bonds to carbon as I can. I'll put the nitrogen on the outside here, and I'm going to attach a hydrogen to the carbon, not to the nitrogen, because I want to make as many bonds to carbon as possible. Now I have to fill octets. Hydrogen's already good because it's got a duet. Carbon, two sides have bonds, the other two sides need lone pairs. Nitrogen, only 2 electrons. To get a full octet, it needs 6 more. So I put 3 lone pairs, 1 on each side. All right, now I make my count. I need 10 electrons. How many do I have? 2, 4, 6, 8, 10, 12, 14. Too many electrons. So I have to go into that erase, erase, replace routine. So I'm going to take away a pair, take away another pair, and replace the missing pairs with another bond. Now I recount. 2, 4, 6, 8, 10, 12. Still too many. I'm supposed to get down to 10. So I have to do that routine again. Take away the 2 lone pairs, put another bond in its place, and then I recount. 2 here, 4, 6, 8, 10. That's the correct number. There's the molecule. Now give this one a try. CH2O is going to have a carbon, 4 dots, 2 hydrogens, and an O. So here's 6 electrons, here's 2 electrons, here's 4 electrons. When I add that all up, I come up with 12 electrons. Now, how do I make a skeleton? Well, I want to make as many bonds to carbon as possible. Not possible to make 4 bonds, but I can make 3. So I'm going to attach my 2 H's to the carbon, and I'm also going to attach my O. Okay, the skeleton's in place. Now I have to fill octets. Carbon's good on 3 sides. It's got 6 electrons around it, but it needs 2 more for stability because 8 is stable. Oxygen, to get a full octet, needs 6 more electrons. So I put those 3 lone pairs in, and now I count. I'm supposed to have 12 electrons in my structure. What do I actually have? 2, 4, 6, 8, 10, 12, 14. Too many. So I erase this pair, erase one of these pairs, and then I go back in and put a double bond between the carbon and the oxygen. Now when I make my electron count, 2, 4, 6, 8, 10, 12. That's the correct number. So that's the structure. Now notice what else happened. Most of the time, almost in every case, once I get the structure the way it's supposed to be, so that it matches the number of electrons I actually have, things get cleaned up. Carbon wants to make 4 bonds. Now after doing this, it is making 4 bonds. Oxygen prefers to make 2 bonds. After doing the structure correctly, the oxygen really is making 2 bonds. Okay, one last one. Water, H2O. Water's got 2 hydrogens and an oxygen. Oxygen's column 6, so there's 6 dots. So 6 electrons here, plus 2 electrons here. When I add that up, that tells me 8 electrons should be in my structure. Hydrogen has to go on the outside, so it's going to be O in the middle, H on the outside. Oxygen needs 2 more electron pairs for a full octet. Now, what's my count look like? 2, 4, 6, 8. It's already good. No double bonds, no triple bonds. I'm done.